Hello and welcome back to JD's Science Prep. Today we are discussing kinematic equations. So this video is just an introduction to the usage of kinematic equations. I will be releasing a more difficult one here in a couple of days. So it says that there are 4 kinematic equations one can use to complete physics problems related to motion. And one of the more difficult tasks when using these is actually figuring out which one to use based on the information you are given by the question. So let's take a look at the 4 kinematic equations here. These are the 4 main ones. Just on the right side, we have a legend for what all of the different variables mean. So we have Vf is the final velocity, Vi is the initial velocity, A is the acceleration, T is the time, and finally D is the distance. So right here we have Vf equals Vi plus At. We have Vf squared equals Vi squared plus 2Ad. Here we have D equals Vi plus Vf over 2 multiplied by time. And finally, last but not least, we have D equals Vit plus 1/2 At squared. So again, this video is an introduction. We're not going to do any manipulations today. That is going to be in another video. So taking a look at number 1 here, it says that a vehicle begins from rest and accelerates at 2.2 meters per second squared for 41 seconds. What distance did the vehicle travel in this time? So like we have done in the past, let's take a look at what we know from the question. So first off, it looks like we are given acceleration. So our acceleration will be 2.2 meters per second squared. And we're also given a time. So our time is going to be 41 seconds. We are also given one more thing. Sometimes this is difficult to pick out, but it says the vehicle begins from rest. So we also know the vehicle's initial velocity. So always look out for the word rest or stopped or anything related to a vehicle or an object not being in motion, because that's going to give you a hint for a variable. So we have A, we have T, and we also have Vi. And the question wants us looking for the distance the vehicle travels in this time. So let's scroll up. Let's take a look at our different equations here. And based on the information that we have, I think we should be looking at the distance equals Vit plus 1/2 At squared. So let's put that into use. So first off, I'm just going to write out the equation that I chose. So again, we have distance equals Vit plus 1/2 At squared. And we can just start putting in our values now. So we have distance equals Vi, which is 0 meters per second, multiplied by T, which is 41 seconds. And that is being added to 1/2 and multiplied by acceleration, which is 2.2 meters per second squared. Finally, multiplied by our time squared. So 41 squared, and I'll just keep the unit there too. Okay, so one thing to notice when using this equation is it's kind of split into 2 different parts. We have part 1 here, and we have part 2 right here. So since we are multiplying Vi and T together, if our Vi is 0, anything multiplied by 0 is 0. So we can just forget about that first part. Okay, because it's going to be 0. 0 multiplied by 41 will be 0. So we can just forget about that. So we can rewrite our new information. So we have D equals 1/2 multiplied by 2.2 meters per second squared multiplied by 41 squared, and we'll keep the unit there. Okay. All right, so we have all of our information written down. We now just need to type it on into our calculator. And if you want, you can pause the video now. And the answer, when you do type it into your calculator, should be 1,849.1 meters. Let's quickly take a look at our significant figures. We have 2 here. We have 2 here. So I am going to go ahead and keep 2 for an answer of 1,800 meters. If you really want to, you could convert this into kilometers. That would be okay. But the question did not require us to do that. So 1,800 meters is the distance this vehicle traveled in 41 seconds when it accelerates at 2.2 meters per second squared. Let's take a look at number 2. Number 2, it says a professional diver dives into a pool and is in the air for 3.1 seconds. What will the final velocity of the diver be, and how far will they fall? So again, let's take a look at some information. We definitely know a time. So our time is 3.1 seconds. And we can assume that our VI is 0 meters per second. And we also actually know one more piece of information. So the acceleration that gravity puts on an object is 9.1 meters per second squared. So we also know that information. We also know the acceleration, just because the diver is, I guess, in other words, free falling into the pool. Okay, so we know T, we know VI, and we also know A. Looks like we are looking for VF, but we're also looking for our distance. So you know what? The first thing that I think we should look at or look for is our final velocity. So let's scroll on up to see if we have anything that would solve for our final velocity using the information that we have. And looking at these, I would say that we can look for final velocity with our first equation. We have VF equals VI plus AT. Let's go ahead and use that one. So I'm going to write that one down here first off. So we have VF equals VI plus AT, and we can just fill in the information that we know. So we VF equals our VI, which is 0 meters per second, plus AT, so we have 9.81 meters per second squared, multiplied by our time, which is 3.1 seconds. And if you type this into your calculator, you should get an answer of 30.411 meters per second. That is very fast. Wow. But with significant figures, our final answer for our VF, we're going to round to, looks like 2 significant figures. So we can say 3.0 times 10 to the 1 meters per second. Yeah, let's put that into scientific notation. Make sure that 0 is significant. So part 1 done. We still have to look for the distance though. So let's go ahead and see if we can figure out a formula to use with the information we have now. So scrolling up here, we have, I think we can use this one right here. We have distance equals VI plus VF divided by 2 multiplied by T. We have all of those variables, so let's go ahead and use that. So I'm going to write that down again. I'm just going to cut this question off a little bit, split it up. So we have distance equals VI plus VF over 2 multiplied by time. So again, let's just fill in our numbers and see where we go with this. So I'm just going to give myself a little bit more room here. So we have distance equals VI, which is just 0 meters per second, plus VF, which is, I'm going to use our first answer here. I'm not going to worry about sig figs for our VF right now. So we have plus 30.411 meters per second, and that is over 2 multiplied by our time, which again is just 3.1 seconds. Okay, so we have all that information now. We just need to type that on into our calculator, and we should get an answer. So our distance is, once you put it into your calculator, it should be 47.14 meters. With significant figures, we can probably keep 2 again. So let's go ahead and round that to 47 meters. And that is the answer for number 2. That is all the examples I have for you. If this video has helped, please like and subscribe. Thank you very much.